Okay, so next I will discuss the vector question in the June 2018 paper. So look at this. With respect to a fixed origin O, the lines L1 and L2 are given by the equations R equals, okay, so they given you the A plus lambda B equation. Here also A plus lambda B, the position vector and the direction vector. So they've given you the position vector and the direction vector for the two lines. Show that line 1 and line 2 do not meet. It's 4 marks. Okay, how do you show that the respective lines do not meet? So first what you do is you try to, you solve it simultaneously, right? You do the normal thing where you try to solve it simultaneously and show that it doesn't work out. How do we show that? So here, let's add them together. -1, -3, 2. You're adding with lambda times 1, 2, 3. So when you add it 1 plus lambda into 1 is 1 plus 1 lambda. Should I write like this? The first equation 1 plus 1 lambda. The other one -3. The y coordinate is -3 plus lambda into 2. -3 plus 2 lambda. The next one 2 plus lambda into 3 is 2 plus 3 lambda. And the next one, this is line 1. And the next one, line 2, R equals 6 plus mu into 1 is 6 plus mu. 4 plus mu into 1 is 4 plus mu. 1 plus mu into -1 is 1 minus mu. Okay, so now what we do is we are actually, to show that they don't meet, what we do is we take the first two equations and we equate them, get the lambda and mu value, isn't it? From the first two equations, we equate the first two equations, get the lambda mu value, and substitute that into the third equation. You substitute the value into the third equation and actually show what? And actually show that the third equation does not work out. It's not going to be equal. Okay, so let's take the first equation. 1 plus lambda equals 6 plus mu. This is equating the x coordinates. So I end up getting here lambda minus mu is 6 minus 1 is 5. So this is the first equation. The second equation I'm going to get by equating the y coordinate. -3 plus 2 lambda equals 4 plus mu. So I get here 2 lambda minus mu equals 4 plus 3 is 7. So either you could do simultaneously or you could just make one person the subject and put it to the other. I think I prefer going with the subjective method. I'll say lambda is 5 plus mu and I'll substitute to the other equation. So here 2 times lambda is 5 plus mu. Minus mu equals 7. So 2 times 5 is 10 plus 2 mu minus mu. Can you see what I did here? I just substituted. Now opening the bracket and simplifying. So I get here 10. 2 mu minus mu is mu equals 2. So mu equals 2 minus 10 is -8. Is that okay? I get the mu value as -8. Okay. And then yeah, so this is 2 lambda minus mu equals 7. Yeah, so the 7, this is 7, isn't it? Then 10 plus 2 mu minus mu equals to 7. So 10 plus mu equals 7. So this gives me mu equals 7 minus 10, which is mu equals to -3. Yeah. So mu equals to -3. Now replacing the mu value and getting the lambda. So lambda will be 5 plus mu, isn't it? Lambda is 5 plus mu, which gives me lambda as 2. So lambda is 2 and mu is -3. Are you with me? And now what do we do? I equated the x coordinate, got the first equation, equated the y coordinate, got the second equation. Now let's go for the third equation. You are going to check by using the third equation. If the third equation with the lambda and mu value, if the third equation is equal to each other, then the lines intersect. But if the third equation is not equal to each other, then it doesn't intersect. So substitute to 3. Substitute to the z coordinate equation. 2 plus 3 lambda equals to 1 minus mu. So if your lambda and mu value, when you substitute, if you can get these two sides equal to each other, then the lines intersect. But if they do not equal to each other, then the lines do not intersect. So substitute 2 plus 3 into lambda is 2. 1 minus mu is -3. Substitute 2 plus 3 times 2, 6. So I get here 8. Over in the other side, 1 minus is 1 plus 3. So that is 4. So 8 is not equal to 4, isn't it? 8 is not equal to 4. So you can cut the equal sign. This is not equal. You can cut the equal sign from the beginning. So here from the third equation, 2 plus 3 lambda is not equal to 1 minus mu. The third equation is not equal to each other. Therefore, what can we say? Line 1 and line 2 do not intersect. Okay, so your line 1 and line 2 do not intersect. So it's extremely important that you use the that you substitute the lambda mu value into the equation that you didn't use. Okay, so I always take the first equation and write the first coordinate and write the and make the first equation. I equate the y coordinate and make the second equation. Solve those to get the lambda mu and substitute to the third equation to check whether the third equation will equate. If it equates, the lines intersect. If it doesn't equate, the lines do not intersect. Okay. So next part, they say the point P is on line 1 where lambda is 0 and the point Q is on line 2 where mu is minus 1. Find the acute angle between the line segment PQ and line 1, giving your answer in degrees to 2 decimal places. Okay. So how does this work? First, we'll get the coordinate. The point P is on line 1. So point P is on line 1. So here 1, 3, minus 2. 1 minus 3, 2 plus lambda is 0, isn't it? Plus lambda is 0. So your point P is 1 minus 3, 2. And point Q is on line 2 where mu is minus 1. So point Q, get point Q, 6, 4, 1 plus mu is minus 1 times 1, 1 minus 1. So when you add this, this is 6 minus 1, that's 5. Here 4 into minus 1 into 1, so 4 minus 1, that's 3. 1 minus 1 is plus 1, 1 plus 1, that's 2. So this is the P coordinate and the Q coordinate. So you can write, these are the position vectors. Are you with me? So I have the position vector of P, I got from the first equation, and the position vector of Q, I got from the second equation. Okay, so do you agree with me? Okay, so then what do we do now? The next thing they ask you to do is find the acute angle between the line segment PQ and line 1. The first thing is what? Get the vector PQ. How do you get the vector PQ? PQ is Q minus P. PQ is OQ minus OP. In other words, Q minus P means OQ minus OP. So OQ is 532. Minus P is 1 minus 3, 2. So we get here 5 minus 1 is 4, 3 minus minus is 3 plus 3 is 6, 2 minus 2 is 0. So I get 460 for PQ. This is okay. Okay, so then the next thing I had to do is to get the acute angle between the line segment PQ and line 1. So what do we have to do here? We don't need to draw any diagram. Now you do realize when you get the theta angle. Okay, you remember what we did, right? So cos theta was A dot B over modulus A modulus B. So in this case, the A and B are what? The A and B, the first vector A, I can consider the PQ vector, and the line 1, the direction vector of line 1 will be the B vector. Do you agree with me? So these two vectors, because they ask you to get the angle between PQ and line 1. So vector PQ should be one vector that we need to consider here for A, and line 1. So when you take the direction of line 1, you don't take the entire thing, you just take the direction vector of line 1, this part. So 1, 2, 3 is the direction vector of line 1. So you get the angle the direction between the vector PQ and the direction vector of line 1. Are you with me? So let's get the direction vector of line 1. Direction vector of line 1 is, what was the direction vector of line 1? 1, 2, 3, isn't it? Direction vector of line 1 is 1, 2, 3. I didn't go to draw a diagram because it's kind of like very obvious here. So then let's get PQ dot, that is A dot B, PQ dot the direction vector of line 1. So direction vector of line 1 is the B here. PQ vector is the A that we are considering here. Okay. So A dot B. So if you get the A dot B here, You have to get the dot product between 460 and 123. So how much is it? When you take the dot product, you multiply 4 into 1 is 4, plus 6 into 2 is 12, plus 0 into 3 is 0. So this gives me the answer. 4 plus 12 is 16. Do you agree with this? And then tell me the modulus of A, the modulus of the PQ vector, 4 square plus 6 square plus 0 square. How much is the answer? Get me the
2 root
answer.
13.
2 root 13. And the other one? 1 square plus 2 square plus 3 square square root.
Root 14.
Root 14. Okay, so now we are ready. We have all the elements that we need here. So now we are going to get the angle. Okay, so the acute angle, do they ask the word acute angle here, or do they say obtuse? Do they say any word? Yeah, find the acute angle. So in the previous question, I was explaining when it's the acute angle, I was explaining you how the dot product, that if it is positive, you directly get the acute angle, but if your dot product is negative, you would get the obtuse. So in here, in this case, you get the A dot B is positive, so you get the acute angle directly, okay? So cos theta is A dot B is 16 over modulus A is 2 root 13 into root 14. So cos inverse of this, and you get the theta answer. How much is cos inverse of this? You get 53.63 something, right? So they want the answer to 2 dp. Yeah, so 53.629, I think, right? Yeah, 53.62985. So 53.63 to 2 dp. 53.63 degrees to 2 dp. Is this clear? Then moving on to part C, they tell you here, find the shortest distance from point Q to the line 1, giving your answer to 3 significant figures. So you have to find the shortest distance from point Q to line 1. Now again, they do tell you here now, because we need to kind of like draw a small sketch to realize what's going on here. They are asking you here to show that the line 1 and line 2 do not meet. So you know these are two lines that do not meet, isn't it? So they are the direction vectors are not the same. Okay, so they have two different direction vectors. However, these are 3D lines. So even though they have different directions, they can go without intersecting. So one line will go beneath the other. Okay, this line can go underneath or it can go above. So, so in this case, even though the directions are completely different, because you are drawing in the 3D plane, the lines, one line is above the other. Okay, so one line can be totally above the other. Okay, so then they are asking you, let's mark all the points now. We know that line 1 and line 2 do not meet. So they ask you to find the shortest distance from point Q to line 1, giving you answer to 3 significant figures. What we'll do is let's mark all the information that we got in part A, B, and C. In part A, we found line 1, line 2 do not meet. Okay. In part B, they say point P is on line 1 where lambda is 0. And point Q is on line 2. So here I'll just mark randomly point Q. Point Q is on line 2, where mu is -1. Okay, so let me just mark P somewhere over here. Random, just mark it at random positions. Okay, point P is on line 1 where lambda is 0. Point Q is on line 2 where mu is -1. Find the acute angle between line segment PQ and line 1. Okay, wait, I have marked both as line 2. Point P is on line 1, isn't it? Okay, point P is on line 1. Find the acute angle between the line segment PQ and line 1. Then you draw the line connecting P and Q. And you have the acute angle connecting PQ and line 1. Am I correct? You already know this theta value. This is what you found in part B as 53.63. Yeah. There is a comment here saying skiv lines. These are skiv lines. Yes, line 1 and line 2 are what we call as skiv lines. Why do you call them as skiv lines? Because these are two lines that do not intersect. And these are two lines that are not having, they are not parallel either. Because they have two different direction vectors. Here 1, 2, 3, here 1, 1, -1. They are not multiples of each other. So these are called as skew lines. Skew lines do not intersect. They do not have the they are not parallel, basically non-intersecting, non-parallel lines. Okay. Okay, then we have here the acute angle between the line segment PQ and line 1. Okay. Then find the shortest distance from point Q to the line 1. How do you get the shortest distance from point Q to line 1? The shortest distance from point, now I have just drawn a sketch here. You could, draw it in any way, just that you can realize that the lines do not meet. So then the shortest distance from Q to line 1 is always the what distance? Shortest distance is always the perpendicular distance. So all you have to do is from point Q, construct a perpendicular to line 1. So from your point Q, construct a perpendicular. Are you capable of constructing? So you can see, just roughly draw a perpendicular to line 1. From point Q, you construct a perpendicular to line 1, giving your answer 3 significant figures. Okay, right. So then the shortest distance here, this is D, the shortest distance from Q to line 1, basically. Okay, so how do we get this D distance? So you can see I already have a right angle triangle here. The theta value is known. The theta value is known. They want it to 3SF. So then how do you get the distance? So what you can first do here is you could get the PQ distance. I think we already got the PQ distance, isn't it? Because we got the PQ vector in the earlier part, and we got the PQ modulus, isn't it? By A, I got PQ modulus, isn't it? When we were finding the equation of the line, the PQ vector was found, and I took the modulus of PQ, 4 square plus 6 square plus 0 square root 2 root 13 is the PQ magnitude, isn't it? So PQ magnitude is 2 root 13. Can you see? This is 2 root 13. The theta value is 53 point, how much was it? 53.63. You could use a little bit extra decimals here. Okay, you could use a few more decimals here first. What was the theta answer? Because when you are substituting the values, it's better to use more decimals than what was here. Wait, let me write the answer here. This was what was the answer? 53.62985. You get something like this, and then you write the 3SF answer. The 2DP answer is 53.63. Okay, because when you are using this answer for the next one, try to maybe use a little bit more significance, because to be safe. Okay, so now what we do is, let's get the D value. So how do we get D? So this is a right angle triangle. You could use either the sine ratio, cos ratio, or the tan ratio. Which ratio works here? So which ratio works here? You can see we can go with sine theta, isn't it? Sine theta is opposite over hypotenuse. Sine theta is opposite over hypotenuse. Do you agree? Sine theta is opposite. So you can see the opposite is D here. And the hypotenuse is next to the 90 degree. This is the hypotenuse. So sine theta is opposite over hypotenuse is 2 root 13. So sine theta. Input the larger value you got. What was it? 53 point. Theta value was. Now they do not want the exact figure here, so you can give the decimal. Give the decimal 53.62985 D over 2 root 13 and get the D value and give the answer to 3 significant figures. So sine 53.62985 times 2 root 13. How much is the answer? Correct to 3SF. So type the whole thing in the calculator, sine 53.62985, or you could say sine answer, because you have the answer stored in the calculator, times 2 root 13. Yeah, and then give the answer to 3SF. Okay, sine answer. The answer was 53 point, sorry, this was a different answer. Yeah. Sine 53.62985 times 2 root 13. And I get the answer 5.8064. So correct to 3SF, 5.81. 5.81. Okay, 5.81 units. We do not have just 5.81 units. Okay, so this is the distance.